Okay, this is the same presentation that was up there, but I changed it just a little bit. Basically, I'm not going to talk about GPSs, but I'm going to talk about how to read the coordinates of them. Okay, covered this a little bit last week. So they gave you a picture, told you to go fix my GPS, fix this sprinkler with GPS enabled. You could do it. All you need to do is figure out where it's at. Did I show you a picture? Oh, okay. Basically, the way GPS works is we have latitude and longitudes. Okay. And the Earth is divided. We're going to see more about that in a second. And when you take a picture, you get this GPS data. You notice right here, the GPS data, GPS date time is missing off that. That's what's up going on with GPS. They changed it. Now, if we get numbers like that, we can convert them many ways. You can go to a website and do it. I'll give you an example there, just like I showed you all last week. Okay, and there's where it turns out to be. Or you can convert it to Google Earth. It'll do it for you automatically. Because it does it. A lot of different applications do it. Or you can search DMS to DD, and it tells you to do this. You're basically converting degrees to minutes. 1 degree is 60 minutes, so on and so forth, and do the math. It's all there. You can do it. I had to write it all out. It's not hard to do.
Do we have to do that?
No, because just use websites like this. It does it for you. I mean, this is a great website. I use this one. You literally select your picture there, and it tells you all about it. And actually, I'm going to show you this one. Let's show you this one. Let's click on this random link that I put in. Hopefully, it's not a virus. Okay, I'm going to choose a file, and I'm going to pick. Oh, those might not have it in it. I think this one does. I think these had stuff in them, didn't they? I'm not a robot.
Oh, God. Did I have to click the pictures? Yes.
Okay.
Now, this is a real trick.
What the heck?
Yeah, we have to do this 3 times. Yeah. Oh, you didn't get it right? Actually, you have to run through at least 3 corrections. Really? Yeah. I think so. Oh.
You get it?
Yeah.
Okay. So it tells me where this picture was taken. It tells me May 5th, 2012, so on and so forth. And I like that it even shows you which angle I was looking at. Isn't that kind of cool? Yeah, it is. It's kind of a cool website. It tells you a whole bunch of information about the picture. So, yeah. Let's open the other one. Which one was that one? That was 22? Crap. What one was that? 22. Let's open the other one, see if it looks different. Okay, view image data. Okay, there we are. Driving into Texas, and you can see exactly which way I was looking. So it is kind of cool. I like this website, so you can use it if you like. So you don't have to do the calculations. I'm just showing you how to do it if you wanted to.
How does it tell which way you're looking?
It knows by the there's a thing where your face. It is in there. There's if you look at the exit data, it tells you which way you're facing, northwest or whatever. It is there. Now, I also found this short little video, which I would like to play for you. It's kind of cool. He did a good job, so I'm going to play it.
Hey, Brain Stuff. I'm Jonathan Strickland. So you've probably seen...
Actually, I'm going to make it bigger here. That way it'll be bigger on the screen for everybody.
Let's suppose that you're writing a really important email to a colleague.
It's not it. Oh.
Hey, Brain Stuff. I'm Jonathan Strickland. So you've probably seen geographic coordinates like these before, maybe on a GPS device or maybe scrawled in a mysterious note you found in the glove box of a rental car. But if you never knew exactly what they meant, fear not. It's actually pretty simple, and we are here to make it all clear. When you see a set of geographic coordinates looking like this, or like this, you're reading latitude and longitude. Latitude represents north-south location, and longitude represents east-west location, usually listed in that order. By combining them, you can pinpoint any spot on the surface of the Earth. These coordinates aren't expressed in units of distance, but in degrees. Why? Because the Earth is a sphere. Imagine a line running from the equator to the center of the Earth, and then another line running from the center of the Earth to the north or south pole. These two lines make a 90-degree angle. All latitudes in each hemisphere can be represented by drawing a third line somewhere between them. So the equator would have 0 degrees latitude, and the North Pole would have 90 degrees north latitude, and a location halfway between the North Pole and the equator would lie at 45 degrees north. Same thing for the southern hemisphere, except you'd call it degrees south. For more precision, each degree of the Earth's surface is divided evenly into 60 minutes, and each minute is divided into 60 seconds. If you need to get even more specific, you can just add decimals to your seconds. Alternately, you can write the whole coordinate in decimal notation. To do this, you have to convert minutes and seconds, which are base 60, into our regular base 10 counting system by dividing each unit by 60 and then summing them up. The results sometimes look counterintuitive, but if you're skeptical, you can pause the video and check out the math. Lines of longitude, also called meridians, run north-south and are used to measure position along the east-west axis. While the lines of latitude run parallel to each other, meridians converge at the poles and spread farthest apart at the equator, like the segments of an orange. Longitude is also measured in degrees, but its 0-degree line is known as the prime meridian, and it runs from the North Pole to the South Pole through Greenwich, England. So, if the prime meridian is 0 degrees, the opposite side of the Earth is 180 degrees, and lines in between are expressed as degrees east or degrees west, between 0 and 180. Since the lines of latitude are parallel, each degree covers about the same distance the world over, roughly 111 kilometers. But because meridians converge at the poles, the distance covered at each degree of longitude varies hugely depending on your latitude. At 20 degrees north, which is about the latitude of Cuba and Hawaii, 1 degree of longitude is approximately 104 kilometers. At 80 degrees north, the latitude of Svalbard and northern Greenland, it's only about 19 kilometers. So, let's say I wanted to go dig up a stash of hot loot from some coordinates I found written in a mysterious note. Even without looking at a map, we can start to make a guess where this would be. Since it's 43 degrees north, it's almost halfway between the equator and the North Pole, again halfway being 45 degrees. And since it's 89 degrees west, it's almost halfway west between the prime meridian and the opposite side of the globe, halfway being half of 180 degrees or 90 degrees. Based on this alone, you can guess it's probably somewhere in North America. But if we use a map or a digital tool like Google Earth, we can zoom in and see these coordinates lead us to the U.S. National Mustard Museum in Milton, Wisconsin? Well, what's the weirdest landmark you've ever found on Google Earth? Paste the coordinates in the comments.
Figure he did a lot better job than I did. It was short and sweet, and he has better graphics. So I figured you'd like to see that one. All right. Okay, so that's how GPS works, at least how to calculate them.